Okay, Assalamualaikum and hi. My name is Muhammad Imran bin Saifuddin, and I'm from CS255, Group 3A. And this is our group project of ITT459, that is Data Communication. And this group project is about concept, theory, and implement a local area network and IP addressing. And below there is our group member list. The first one is Muhammad Imran bin Sarifuddin. It is me. And Abdul Syakir Imran bin Abdul Salim, Muhammad Akmal Haikal bin Azhar, Fatin Syafiqah bin Zulkafli. And then this is our picture. Okay, and then I will pass to the next group member to explain.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Akmal Haikal bin Azhar. Today I want to share with you our case study about local area network and IP addressing for the small and medium enterprise. So I will explain to you truthfully about what is LAN, what is WLAN, what is IP address, size of LAN, and I will show to you our network topology. Okay, so next. Okay, what is LAN? A local area network is a collection of devices connected together in one physical location, such as building, office, or home. Regardless of size, a LAN single defining characteristic that it connect devices that are in a single limited area. So we go next. What is WLAN? WLAN. A wireless local area network is a group of collocated computers or other devices that form a network based on a radio transmission rather than wire connection. Wi-Fi network is a type of WLAN. Like broadcast media, WLAN transmit information over radio waves. Data is sent in packets. So we go next, yeah. So what is IP address? An IP address is a unique address that identifies a device on the internet or a local network. IP stands for Internet Protocol, which is the set of rules governing the format of data sent via the internet or local network. In essence, IP addresses are the identifier that allow information to be sent between devices on the network. They contain location information and make devices accessible for communication. So next, the size of LAN. The physical size of a local area network LAN can be determined by its purpose and the type of technologies that are used to build it. For instance, with WLAN, this is usually sized depending on the overall area of coverage of the individual access point. However, with a network that runs on the Internet Protocol, this will usually reach out as far as the physical reach of the internet cables allow. In both of the above instance, a LAN can actually be extended in order to cover far greater distances if this is required through the aggregation of a multitude of switches or access point. For our use case, we're using LAN because it is easier to manage for small and medium enterprise SME. Okay, so this is basically our network topology. This is only the picture. My friends and I will explain it on the Cisco packet tracer. Yeah, sorry. So this is network topology, physical intercity topology, which is the whole. We have HQ City, Penang office, Johor office, and the data center. So the left is the topology of HQ office. This is Penang office topology. the left is Johor office topology, and the right one is the data center topology. Okay, so I will pass to my friends to explain about our case study.
It is me again, Imran, and we will be doing a demonstration for our network topology in this packet tracer. The first thing, I will try to message from the PC1 HQ to the other network for Penang, Johor, and the data center. First, I will add the simple PDU to this. This is the source, PC1 HQ, and I will ping the PC1 Penang, and let's see. Okay. And then okay. Okay, it was successful, and we will try from PC2 HQ to PC2 Johor, or laptop 1 Johor. Okay. And then you go to the Johor network. Message process and come back. And the last status is successful also. And we will try to send a message from PC3 HQ to the first server in data center. And there is go. And server change back. Status is successful, and I will pass to our other group members.
Assalamualaikum and selamat sejahtera. My name is Nurfati Syafika binti Sukabli, and my matrix number is 2022970411. So for my part, I will explain and do a demo on how to verify HTTP and HTTPS after we have configured the web server. So firstly, we need to click on any PC or laptop at any host. For example, I will use the PC at Penang branch, and then we click the desktop and click the web browser. Here at this space, beside the URL, we need to put in the IP address of the server. I will use the IP address of server 2, which is 192.168.103, and then we click on the go button. Here, a website which have been set up in the server before will appear. As for HTTPS, we just need to put S at the end of the HTTP and click the go button again, and result will be the same. But HTTP and HTTPS are both option for the start of a URL, but the difference are quite a bit, which I can say. HTTP is a no data encryption implemented. Every URL that begins with HTTP use a basic type of hypertext transfer protocol. This network protocol is what allows web browser and servers to communicate through the exchange of data. Meanwhile, for HTTPS, it is a encrypted connection. Simply put, HTTPS protocol is an extension of HTTP. The S in the word HTTPS stands for secure, and it is powered by transport layer security, and it is the standard security technology that establish an encrypted connection between a web server and a browser. So this is my explanation on how to verify HTTP and HTTPS. Thank you.
Okay, so now I will ping from device to device. I will show you truly. So the flow is laptop to PC, PC to router, PC to router, PC to router, PC to PC, and the local network. Okay, so I will go fast. Okay, so please 192.168.2.14. I will ping to the local network first. We'll test the connection. Okay. So the ping is successful. Ping on the we test the local network already, but I will test one more time. We'll test to the TC2. Yeah. Okay, so successful. Okay, so next I will ping to the router, to the local router 192.168.2.72. Okay, so we get the reply. The connection is successful. So I will ping to the other router 192, the Penang router 192.168.6.1. Okay. Okay, so the ping is successful. I will ping to the PC 192.168 Penang PC 192.168.6.100. Yeah. Okay, so successful. So I will ping to printer just for fun. All okay. Forgot the command 192.168.6.100. Okay, so the connection complete. So now we'll test to the same network. I will test one time to the printer 192.168.6.100. Okay, so the printer is reply from the packets we sent. So I will ping to the local network router 192.168.6.1. Yeah. Okay, so the Penang router on the local network on Penang router on the Penang, the local network on Penang is successful. The connection is good. So I will ping the router on HQ 192.168.2.1. Yeah. So the connection very good. Okay. So now I will use HQ to data center. data center. First we go to the router 192.168.4.2. Oh no, from the 4 to the cable .1. Okay, we receive packets. So we ping to the one server. Any server, I will choose server 3 .10.4. Okay, so we receive the packets. So I will try to ping on the local network on the data center. So we go to command ping. We ping server 5 192.168.10.6. Yeah, 10.6. Yeah. Okay, so no losses. So I will try to ping to the local router, which is data center router 192.168.10.1. Okay, so the connection is on the local area, local network is good, successful, no error. So just for fun, I think I can ping to HQ 192.168.2.1. Okay, and now I will ping to the Penang 192.168.6.1. Okay, so now, okay, for the last one, I will ping from HQ to Johor. Okay, now we'll ping from PCHQ to the router on Johor. Ping 192.168.8.1. Yeah. So connection successful. Ping was received. I will ping to the PC next 192.168.8.10. Okay. Okay, nice one. No error whatsoever. Okay, so I will try ping from laptop to the PC off to the router. I will choose Johor. Laptop 3. Desktop. Ping 192.168. I choose to the printer. Right? Why not? Okay, successful. Okay, now so because all the network must connected to the PC, to the HQ. So the last one I will ping Penang to HQ, server to HQ, and Johor to HQ, to the PC. Okay, to the PC on HQ. Okay, for the last one, this is a laptop on Penang. I will ping to PC2 192.168.2.11. Okay, we get the reply. So that's from laptop. So now we choose server 4 server 4 to router to PC4. Try PC4 right here. Okay, 192.168.2.13. 192.168.2.13. Because somehow, yeah, we get the reply for sure. No error whatsoever. Okay, now from laptop, we choose laptop 3 from Johor to PC5 lah. Okay, the last one. 192.168.2.14. Okay, so we get the reply. The connection was successful between the network on HQ, Penang, Johor, and data center. So that's all from me. Thank you.
Okay, my name is Abdul Shakir Imran bin Abdul Salim, 2022793653, and I'm here. And right now, I want to talk about the data center network. So, the data center network here, the subnet is 192.168.10.0, and it's using the prefix 24. Subnet mask 255.255.255.0, and number of server hosts is 5. So all the server is connected to the switch, and the servers must have the HTTP, HTTPS, and FTP services. Okay, now we continue. So here I want to verify if the FTP is working or not. So here I will use server 1 and using the HQPC. So the HQPC, I will create a text. So I create a secret message. Secret.txt. So here I will use the FTP. Let me check the file first. Directory, we have the secret.txt, and then we use the FTP 192.168.10.2. Username Cisco, password Cisco, and then we use the command put secret.txt. So right now the file secret.txt is transferred. So here in the server should have the file FTP 191.168.10.2. So here we have the file secret.txt. So right now I want to get the file on Penang and Johor branch. So right now I will use this PC. Cisco get secret.txt. So right now you should have the file in this directory of the PC from Johor, secret.txt. So right now we try on Penang PC. We try on this laptop. Command from FTP 192.168.10.2 Cisco get secret.txt. So right now the transfer is complete. So we exit, check the directory. We should have the secret.txt. So here it shows that the FTP is working fine.
And lastly, for our demonstration is how to show the device that connect to our network using command prompt. It is ERP-A. It will show the IP address and the MAC address for the device that connected to our network. And then for the tools to monitor the network, such as Zabbix, Net Data, PRTG, Nagios, and any other. It is an open source software tool to monitor network. It is to make it easier for our network operation team to quickly respond to the network outage. And that's all for our demo. Also, we are very sorry that we forgot to config the VLAN IP address for each of the switch. And that's all from us. Assalamualaikum and thank you for watching.